Okay, boys and girls, what I've done, I decided to just record another video, like really focusing on more than likely, so you can focus on what's going to be in the first series. So I gave you through the Google Classroom some that I recorded during tutorial. I don't think it was the best video, so I decided to do one right now with you all. Okay, so so I'm gonna go over these. Hopefully you can see better. So let me get a pen. There we go. So this one says choose all the information that will be included in your credit report. So anytime that we're working with credit report, they're gonna check if you give your payments on time. So if you have late payments, your credit report is not gonna be good. If you give your payments on time, your credit report is gonna be good. So credit report, of course, they're gonna be looking at your payments. That would be something that would be included. The number of credit cards, well, that deals with credit. They want to know, do you have a lot of credit cards? Do you owe a lot of money in credit cards? Do you pay the credit cards quickly? That will be in your credit report. That's why it's called credit report. Late payments, you have to give payments for credit cards. So all these two will be on your credit report. Your high school grades, that would not be important, not for your credit report. That would not be included in your credit report. So high school grades will not be included. Your middle school grades will not be included. Previous employers, these are where you work. That's important. They want to know, do you have a good history in jobs, or do you quickly leave them? Are you steady with a job? So your payments, your credit cards, previous employers, all that is included in your credit report. Also, if you owe like a house, if you owe a car payment, if you have a mortgage, some car loans, all that will be included. So late payments, that's part of your credit report. The credit cards that you own, that's part of your report. The employers, where have you been working, that's part of your credit report. Your home, your address, that's going to be part of your credit report, just to see if you move it out around. So credit report is a report that tells people if you're good with your payments, your credit cards, how you have them, how many you have, and where you work, your house, if you own cars, all that will be part of your credit report. Now, high school grades, that's not part of your credit report. That will be important for scholarships later on. The next one is about, so that's the credit report. This here was about the credit report. Now, this one is about your debit and credit cards. Some of you still have trouble with debit and credit. Debit cards is your money. You have that money in the bank. Credit cards, that is not your money. You're borrowing it from the creditor, from somebody who's lending you money so you can go buy. You have to pay it back. So I wanted to know which ones are true. Debit card purchases withdraw money directly from the bank account. Since it's debit, it is your money, so it's going to come from your bank. So this would be true. Money is borrowed when you use a credit card and you must pay back. Well, it's a credit card. That means that you did borrow it and you have to pay back. That would be true also. Interest is charged when you use your debit card. Interest is charged. Debit card. That is false. This is not true. Why? Because the debit card is your money. How can they charge you for using your money? So interest will not be charged with debit card. That's why this is not true. It's saying that it will be charged. No. Now look at the next one. Interest is charged when you use your credit card. Now that's true. When you use your credit card, they're going to charge you interest. unless you pay the whole amount quickly. But interest is charged when you use your credit card. Interest charged when you use your debit card? Not true. You get interest charged when you use your credit card. The amount you spend on credit card depends on your age. So again, it's credit card and the amount spent depends on your age. That is not true. Your age does not matter. If you're a 40-year-old, if you're a 20-year-old, the amount you spend on your credit card will not depend on your age. The amount you spend on your credit card depends on your credit limit. Now that's true. Credit card depends on your credit limit. So every card that's a credit has a limit. Depending on your credit report, you have a higher limit. If your credit report is good, that your payments are not late, you don't have that many credit cards with that they're all maxed out. You have a couple of them that you use and you pay them quickly. Your employers, you have a steady job always. Then your credit limit will be high. That means that you can spend more on your credit card. But if your credit limit is low, that means that you cannot spend more. So yes, this is true. How much you spend on your credit card depends on your limit. How much do you have to spend? So that's true. The amount you spend on debit card depends on the balance in your bank account. Well, since it's your debit card, it will depend on your bank account. So if I only have $100 left on my bank account, I can only spend $100. So this is true. Debit card depends on the balance you have in your bank account. The last one, the amount of money you spend on debit card depends on your weight. Debit card is your money that you have in the bank, so that should not depend on your weight. If you're very heavy, doesn't mean you're gonna have more money in the bank. If you're very light, does not mean that you have that does not depend on that. So the debit card spending depends on what you have in the bank, which is letter H. So this would be not true. So a quick summary is this. Debit is your money. Credit is not your money. That's you have to pay back credit, and debit you don't have to pay. So debit is withdrawn directly from the bank. Credit is borrowed, you have to pay it back. Interest is charged on credit because that's not your money, so they want to get money out of you for using their credit. The amount you spend on a credit card does not depend on your age, it depends on your credit limit. How much money you can spend on a credit card depends on the limit that you have on the credit. The debit card does depend on your bank account. How much you have on the balance of the bank account. That's how you're gonna know when you can use a debit card. And finally, the debit card does not depend on your weight. Okay, the next one. I'm just gonna do one. You can practice the other ones by yourself. So this one we have they have 85 grams and they want it in milligrams. So if you go to your math chart, it will tell you that 1 gram equals 1000 milligrams. That's what the chart tells you, the conversion chart that you're gonna get. What Mr. Rivera prefers you do is a proportion. So this part came from the math chart. 1 gram equals 1000 milligrams. From the conversion chart that you're gonna get, that's where this came from. Mr. Rivera wants a proportion, so I need to know where to put the third number. The third number is 85 grams. Since 85 grams is in the top, I'm going to put him on the top. And milligrams is on the bottom, so he gets the X because that's what they're asking for. Whomever they're asking for will get the X in a proportion. Now 1 times X will be 1X, which is just X. 1000 times 85 would be 85. And then we have how many zeros at the end? 3. 1, 2, 3. And that will be my final answer. X equals 85,000, which is letter A. Okay, now I could have done this one again, same thing, 48 feet, and they want it in yards. If you go to your chart's going to say that 1 yard equals 3 feet. Now we have 48 feet, that would go on the bottom, and this one will be on the top. So we'll go 3 times x, 3x. Again, this ratio came from the chart. 1 yard equals 3 feet. The 48 was from the story. Anyway, 3 times x is 3x. 48 times 1 is 48. Now in this case, we're not done because we need to solve for x. So we're going to use sat m to help us solve for x. A number next to a letter means multiply. So to solve for x, I'm going to do the inverse, which is to divide by 3. What you do to one side, do to the other. Now these two 3's cancel. Bottom out, 48. You go to the side, divided by 3. Bring on the 8. Times 6 would be 18. So my final answer is x equals 16. So yards would be 16, which is letter B. You could try that one by yourself. Same thing. You set up your proportion based on the mathematics chart. Okay. The next one. Here we have Hugo answered 6 out of the last 25 questions correct in his last test. What percent is equivalent to 6 out of 25? So all they need here is come on. All they need here is the percentage that is equivalent to 6 out of 25. Since they want a percent, I have an option. I can do proportions, but since they mentioned that they just want something to be equivalent, I'm just going to create a fraction quickly. And 25 out of 25 means 25 will go on the bottom. 6 are the questions that he answered correctly. They want the percent of 6 out of 25, so there's my fraction. Now I need to bottom out so I can figure out which one is it. So I go to the side, 6 divided by 25, bottom out, put your decimal. 0 is not enough, add a 0. 16 is enough, times what? Times 2 would be 50. That's it, 2. 0, 1. Now 25 times what gives me 100? Well, 25 times 4 will give me 100. So the decimal is 0.24. So we're going from fraction to decimal now, but the things I need to go to what? To percent. So how do I switch a decimal to percent? We move twice to the right. 1, 2. That means that it would be equal to 24%. So the percentage that's equating to 6 out of 25 would be 24%. That's how I would do it. You could have done a proportion too. I think that that's the best thing to do. The next one, just so you can get it, this one is like the same thing. You can go practice this one by yourself and see if you can get it. They want again an equivalent of percent. So you have to make a fraction out of this. Remember, to make a fraction, the total goes on the bottom, what they're asking goes on top. Okay? Let's look at this one. Use a table to complete the statements. Choose the correct answer from each drop-down menu to complete the sentence. So there's going to be a drop-down menu. Let's aplicar aquí. And you're going to finish the sentence. So again, here's what they want. They want the percent of reading. So what we can do, we can set up a proportion here. Okay, or you can do it the way I did up there. Fraction, this 1% doesn't matter. I'm going to set up proportions, you can see. Since they want a percent, I know percent means out of 100. Since they want a percent, he will become the x. Now 100 in math, of a percent will be the total. And the X is what they're asking us. So let me read. The percentage of students who chose reading. So the X would be reading. I'm gonna put on read. I'm just gonna put read. Okay. Now we already know that reading is 10, so I know that 10 will go on the top. But we do not know the total. So to get the total, I'm going to add them all up. 10 plus 10 will be 20, plus 15 will be 35, plus 5 will be 40. So the total is 40. Once you have that, guys, it's just your proportion. 40 times x will be 40x. 100 times 10 will be 1000. Divided by 40, that cancels. Divided by 40, those zeros at the end cancel. 100 divided by 4, x equals 25%. So 25% of the kids chose reading. Okay? And the next one, it says Jada, or over here first. The cost of 1 pound of cheese is $2.50. Valentina bought 1.5 pounds of cheese. What was the total cost of the cheese Valentina bought? Okay. So the question wants the total cost. That's the question. Now the cost of 1 pound is $2.50. So I know that $2.50 is the cost per 1 pound. Valentina bought 1.5. That's what she bought. So if you buy 1.5 pounds and it's $2.50 per pound, this tells you $2.50 per pound. That means I'm gonna multiply 1.5 times 2.50. Now the problem is that this is in fraction, this is in decimal, so we need to change either the decimal to fraction or the fraction to decimal. I think we're better changing this guy to money. So 1.5 means $1.50 times 250. Okay. Now, when you're multiplying decimals, if there's zeros at the end, you can just remove them for now and multiply only with, like if they're wholes, 25 times 15. 5 times 5 would be 25. 5 times 2 would be 10, plus 2 is 12. Cross it out and put a 0. 1 times 5 would be 5. 1 times 2 would be 2. So it's 375 right now, but then we need to put the decimal back. So we have here 1, 2. So when we remove the zeros, we don't count the zeros. We just count what we have. 1, 2. So I'm going to go backwards. 1, 2. So she will pay 375 for the cheese. That's how you do these. So make sure that if you have a fraction, a mixed number with a decimal, we need to put them all decimals by bottom up. This one is like that one, so you can try that one by yourself. This one is like that one, so you can try that one by yourself. Okay? Get rid of this. Okay, I'm gonna try this one. This one. A chemistry teacher has 18 boxes of baking soda for students to use in an experiment. If each student will use two-thirds of a box of baking soda, how many students can perform the experiment? Okay. In math, guys, when you see a fraction right next to the word of a box, I know that this means two-thirds. The word of means times, because a fraction next to the word of will mean times. Okay, box, well, the only one that has boxes is the number 18, so 18 will go here. Now to multiply a fraction times a whole, we have to put a 1 on the bottom. Then we'll go Superman across. 2 times 18, you go to the side if you need to. You go calculate on the side. That would be 36. 3 times 1, that would be what? 3 times 1, that would be 3. Bottom out, 36 divided by 3. I can put 36 divided by 3. So now I know that two-thirds of the 18 box would be 12. So that would be the answer, 12. Okay, this one, like I said, you can try it like that one, just so you can practice. The next one. Okay, the next one we did this last week, guys. We have equation y equals 2x, and we're trying to find which graph belongs to this equation. So whenever you have a graph, I already told you that we're going to create a chart, a table with x and y. So go to your first point right there. The first point we see there is 0, 0. The second point we see there is 2, 4. And what's the third part? What's the third point? I'm sorry. The third point would be 4, 8. This is for choice A. By the way, this would be A, this would be B, this would be C, and this would be D. So that's what you first have to do. Get the points and make your table so we can figure out the equation. Now besides that, this is a multiplicative, and if it's a multiplicative, that means that choice B is already done. Because multiplicatives, it has to go through the origin, through 0, 0. So this is done. This one is also done because it goes through the x-axis. So D is done. This one, yep, it goes to the origin. This one, yep, it goes to the origin. So right now we're testing this one. So I told you that we always like to use the last two. Y equals 2x. Y, you see the Y right there? That would be the 8. Okay. So why did the Y become an 8? Because the Y shows 8. 2, the X, you see the X right here? And we always use the last one, the X is 4. Now a number next to parentheses, a number next to a letter means multiply. So 2 times 4 is 8. And they're equal. So choice A is probably the answer. But we still have choice B because they also went through the origin. So choice B, I'm going to draw my table. Your first point here is 0, 0 again. So 0, 0. The next point is 2, 1. The next point is 4, 2. Once you have your table, It's time to use your equation to test it out. Okay, so again, I like to use the last one. Y in this case is 2. If we use the last one. And the number next to that means multiply, and x is 4. 2 times 4 is 8. That does not equal, so that's why choice B is dumb. And choice C and dumb, I don't have to even try them because they didn't even go to 0. When it's a multiplicative, a number next to letters, it has to go through the origin. Okay? The next one we have an expression to solve of here. And of course, we need to use pandas. And we need to use the rules because there's negatives everywhere. So let me write the first problem. I know it's going to be pandas that I'm going to need. And the rules. So the first thing to check if there's parentheses. So we do have parentheses there physically, but is there an operation to work inside? No, there isn't. Do we have exponents, the little number in the corner? No, we don't. Do we have multiply or divide? Yes, we do. We have multiply here and multiplier there at the end. So you go two at a time, left to right. Now 4 times 2 we know is 8, but because we have a negative, when we're multiplying, the rule that we're going to use is Dorito Man. We have a positive and a negative, so we circle those. Whatever you don't circle, that would be the answer for the 8. It will be negative 8. I'm done with these two numbers now. Everything comes down carefully. Everything comes down carefully. I'm gonna go back to my checklist. Do we still have multiply and divide? We sure do, right here at the end. So guess what I need again? That Dorito guy. We have a positive right here, the 3 and a negative. So the answer is gonna stay negative. So 3 times 8 would be 24, negative. Okay. I'm gonna do one more and then you can practice this by yourself. So this guy right here. This one you have to be careful because we have a double negative right there. When we have a double negative, we have to rewrite. So this really becomes 35 plus 110 in parentheses divided by 5 times 2. This is a double negative rule. When you have double negative, they become plus. Now we're going to use PEMDAS so I can know who goes first, who goes second, and so on. So we have a plus, we have a divide, and we have a times. So let's start with parentheses. We do have parentheses, but nothing inside. Exponents, and there's no little number in the corner. Multiply, divide. Yes, we have divide and multiply. This guy will go first because it's left to right. So 110 divided by 5. Go to the side. So 110 divided by 5 would be 22. So you put that one. Everything else brings down. So the times 2 comes down. And the plus 35 comes down. Who would be next now? This guy would be next. Because it's still multiply and divide. 22 times 2 would be 44. I'm done with multiply and divide. The last step would be add. 35 and 44. This would be 79, the final answer. Now, don't forget if you have a double negative, you have to take care of it. Like here we have a double negative, we have to take care of it, and then we can continue. Don't forget when we multiply or divide is Dorito Man. The next one. This is again a true and false statement so you can practice. So you try them all. So let me go over the rules. This one we have a negative plus a negative with a rule that we need is called same. And same means to add and keep. So 4 plus 3 is 7. That's what we do first, add. And then we keep a negative, negative 7. So this will be true. The one not true. The next one we have 8 times 2 equals negative 16. Well, that would be Dorito guy. Why Dorito guy? Because we're multiplying. We have a negative and a positive. We circle those. So the answer should be negative, which it is. And what's 8 times 2? 16. This is true. The next one, we have a double negative. I just talked about that. That double negative becomes plus 2. And what's 3 plus 2? 5. This will be true also. It must be that one, but we need to check. 12 divided by negative 12 divided by negative 3 equals negative 4. So I will need the Dorito man again. We have negative, negative. The answers will be positive, and that's already a problem because they have a negative. So this is not true, and this will be the answer because they want to know which one is not true. Okay, the integer rules. This is next. So they want the total points. So since they want the total points, I get a pen again. So since they want the total points, I need to look at this side of the table. We have 2 plus negative 4. Total points means to add them. Plus negative 1 plus 1. I got them from here. And why am I adding them? Because they want the total number of points. We start with the first one. That would be diff. Because the signs are different, and when it's diff, they're different, we're going to subtract. And we're going to keep the greatest absolute value. So 4 minus 2 will be 2. And we're going to keep the 4 negative because the negative is highest absolute value than 2. Now bring everything down, bring everything down, bring everything down. Now these two will be next. Now both of them are negative, so I'm going to use the rule same, which means to add. 2 plus 1 is 3. And the E means to keep. We keep negative. Now we bring everything down, and finally we have diff, which is this one. And 3 minus 1 is 2. Who wins in the absolute value? The negative 3, so the answer stays negative 2. So you just go in order 2 at a time, guys, and don't forget to use the rule. The first rule was diff, then it was same, then at the end was diff again. Okay. Okay, here we have again. I'm gonna do the second one just so we can see, and then you can do that one by yourself to practice. So let me write the second one. I'll write it up here. 3 to the third power minus 4 times 5 squared minus 10 minus 3. So obviously we will need PEMDAS. I'm going to need rules if we need them. So do we have parentheses? Yeah, we have here parentheses, but there's an exponent and a minus. So I will take care of the exponent first. Now I already told you, I don't know how many times, guys. Exponents, you have to go to the side and rewrite it. So if I go to the side, 5 second power, that means 5 times 5, which is 25. So this becomes 25. Everything comes down, including the parentheses. Over here we have a 4, including the 3 to the second power. Go back to your checklist, and we still have parentheses. So 25 minus 10, that would be 15. Since I'm subtracting, I need to know who has the highest absolute value, which in this case would be 25. So I'll keep it positive. I'm done with those two where the caret is right there. Those two numbers I'm done. I don't have to worry about it. Now we have to worry about the minus 3. We have to worry about the 4. Now a number next to parentheses minus, we'll put it. That means times. Put the dot already. Okay. Now I go back to the checklist. I don't have parentheses anymore. I mean, I have them there, but there's nothing to do inside. Exponents. Oh yes, I have another exponent right there. So let me put a caret there and go to the side. 3 to second power means 3 times 3. It's actually to the third power, I just noticed, but I don't know why. So it's really 3 times 3 times 3. 3 times 3 would be 9. 9 times 3 would be 27. So 3 to the third power is 27. Bring everything down. Bring everything down. Bring everything down. Go back to your checklist. We have exponents done. Multiply and divide. Right there. You go to the side. 15 times 4. 60. Bring everything down. Bring everything down. Go back to your checklist. Multiply and divide is gone, but we have add and subtract. We have subtract, subtract. So when you have two, I already told you, go left to right. Oh, we have a positive and a negative, so the rule is diff with the greatest absolute value. So in this case, I'm going to go to the side. 60 minus 27. 10 minus 7 would be 3. 5 minus 2 would be 3. So this would be 33. Now positive or negative, 60 is larger. No, not larger. It has the highest absolute value. Higher absolute value than the 27. So there's a minus in front of that 60, making them a negative. So this becomes negative. Bring everything down. There's the last two. That would be same. So we have a negative and a negative. So what do? You're going to add, and you're going to keep. So 33 plus 3 will be 36. And then we're going to keep a negative. That would be your final answer for this one. You can practice this one by yourself. The next one is real simple. You need to make sure that you check. Let me show you the number line. When you have a number line, a model of what's going on, you need to just go check where the arrow is. So we already started from here because there's no arrow. So it started jumping in groups like this. And they ended up at the end at 0. So what they're trying to tell you is that this number line represents 0. That where it stopped, the answer is 0. So my job is going to be in check. Which one of these will give me 0? Well, let's start with the first one. Negative plus a negative. That would be the rule same. So I'm going to add and keep. And if I add and keep, I don't get 0. The next one, we have 2 times 4 would be 8. But I'm multiplying negative. So I'm going to need the Dorito man. We have a negative and a positive. So I'm going to circle the negative and positive. Whatever you don't circle, that is the answer. So it will be negative 8. Or negative 8 still. The next one, we first do this guy. 2 times 4 would be 8. and negative 8 plus negative 8. So negative 8 plus negative 8. Not negative 8, my bad. 2 times 4 is 8 plus 8. Now we have adding of a negative and positive, so the rule would be diff, which means to subtract. So 8 minus 8 would be 0. So the answer would be 0, which would be that guy. The last one just tested. 8 divided by 2 is 4, but we need the Dorito guy. This time we have two negatives, so the answer will stay positive. Okay? The one that will give you the 0 is letter C. Okay? Hopefully you understand it now. The next one. Let me pause quickly. Let me see how many more slides we have. Couple of. So I'm gonna pause quickly. So hopefully this will help you. I'm gonna pause right now quickly. Okay, we'll continue. I have to drink some water. Okay. The next one. Okay. This one we have out of 350 people in sixth grade, 32% scored masters in the STAR test. How many of the students did not score masters? So you have to be very careful when it's story prompts. So the question is how many students did not score masters? So that's my question. They want to know the ones that did not score masters. Out of 350 people. So you know that 350, that is the total. Why? Because I already told you that out of means total. Now 32%, those are the ones that scored masters. So these are the masters kids. And that's all they want. They want now the ones that did not. So I already told you when we're working with percentage, I would want a proportion. Now they're not asking for equivalency. The other ones we have, like when sometimes they'll ask you for an equivalent, you just go fraction decimal percent. Bottom out, move twice to the right. This one they actually want to know the quantity of the percent that did not score masters. So I'm going to set up a proportion. Now percent in math always means out of 100. 32%, that would go on the top because that's the percent. Now labeling is so important when we do proportions. So the 100 would be the total, and the 32 would be the masters. Now the 350, we said it's also the total, so I'm going to put them on the bottom. And we'll put an X here because we don't know the quantity. We know the percent is 32% of the masters, so we're going to figure out what the quantity is. So now that we have our proportion set up, we're going to go 100 times X would be 100X. 350 times 32. I'll go to the side. 350 times 32. Calculator kids just punch it in. 2 times 0 would be 0. 2 times 5 would be 10. 2 times 3 would be 6 plus 1 would be 7. That would be 700. Cross it out and put a 0 because we're going to the next place value, which is the tens. Cross out that 1 so you won't forget about him. 3 times 0 again would be 0. 3 times 5 would be 15. 3 times 3 would be 9 plus 1 would be 10. 0, 0, 7 plus 5 would be 12. 1 plus nothing would be 1, and 1 again. So it's 11,000 200. How do I solve for x? We do the inverse of multiply is divide. X is by himself, that's what we want. We have two zeros at the end to drop two zeros over here, cancel. 112 divided by 1 would be 112. Now, many kids will stop there, but look, this 112 at this moment is the ones that scored what? Masters. That's why we have to look at the labels and read. So this 112 is the masters. They're not asking for the master, they're asking for the non-masters. So what do I have to do? I'm going to have to go 350 is my total, minus the masters so we can find the ones that are not masters. Now I have to regroup. This guy becomes 10. This guy becomes 4. 10 minus 2 would be 8. 4 minus 1 would be 3. And 3 minus 1 would be 2. These are the ones that are not masters. So we really have to be careful. We did solve for x, but that was the masters. They wanted the non-masters, so I have to, at the end, 112 would not be my final answer because that's the masters. That's why we need to read the labels. I have to, at the end, subtract from 350 so we can find the other part, which is the non-masters. So the real answer is 238. Try that one by yourself so you can see if you understand. It's the same type of problem, so you can see if you understand it. Okay, now the next one. A math teacher has 27 problems in the test. If the test has 2/3 of the problems being algebraic reasoning, how many problems are about algebraic reasoning? Well, whenever you see in mathematics a fraction next to the word of, that means multiply. So 2/3 of means times of what? Problems. So 2/3 of times problems. So how many problems are here? I see that there's 27. So 2/3 times 27. When we're multiplying a fraction times a whole, we need to put it as a fraction. So we just put a 1 on the bottom. That takes care of that part. Once you have your fraction set up, we're going to Superman across. 2 times 27, you can go to the side, and you should be getting 54. Superman across, 3 times 1 would be 3. The answer right now looks like 54/3. Some kids will choose C, but no, you're not done. You need to go bottom out. C is not 54/3. We need to bottom out. 4 divided by 3 times 1 would be 3. Putting on the 4 times 8 would be 24. So how many were algebraic reasoning? 18. So again, when you have the word of next to a fraction like 2/3 of, you quickly know it's 2/3 times, and then the word problems, we'll go get the problems, which is from the story 27, and which is Superman across since it's a fraction. The next one, these are descriptions. You're gonna read and create an equation or something. So I'm gonna go over this, the word equation, and they want the description, which is they want it in verbal, a verbal representation. So here's how it works. Letter A number. I do not know what number it is because they just mentioned a number, so I'm going to use X. Is less than or equal. That is the symbol. Is less than or equal. That's that symbol. It's an inequality symbol. Less than or equal. 2, -8 and 4/10. 2, -8 and 4/10. This is not an equation, it's an inequality. They don't have the equal sign. So that's why letter A is dumb. B, a number. I do not know who that number is, so I'm going to call it X. A number will be X. Minus means minus, subtract. 5, put a 5. Is, oh, that's so important. This is by himself, not like this one. This one said it is less than or equal. This one is just is. When you have is, just like that. In mathematics, the word is means equal. Is what? 27. Now this is an equation because what's there? The word equal means is. So letter B is probably the answer. Letter C, so we can practice quickly. 9, letter C, 9 times a number. A number next to letter means times a number. 9x. 9 times a number minus 30. Minus 30. There's no equal sign that they're trying to find an equation. The equation has to have an equal sign, so letter C is called an expression, not an equation. Letter D, a number. I do not know who that number is. To the fourth power. Oh, the little exponent to the fourth power. That's not an equation again. There's no equal sign. So the answer is B. You can try this once by yourself so you can get the hang of it. The next one. We have a number line. We have a number line. I want you to do the bottom number line. Okay? I'm doing the bottom number line. When you have a number line that's already drawn with the 0 all the way to a hole, in this case, we already know that the whole thing is one hole. But we need to find out the pieces. So what you're going to do, you're going to count. From here to here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to get the whole, I need 10 out of 10. So if this is 10 out of 10, this must be 9 out of 10. And this must be 8 out of 10. And this must be 7 out of 10, 6 out of 10, 5 out of 10, 4 out of 10, 3 out of 10, 2 out of 10, and 1 out of 10. Is it always going to be 10? No, it could be cut erase. Just remember that we're counting from here to here, 1, from here to here, 2, from here to here, 3, and so on. That's how we got the tens. Okay? Now they want me to find the 2 points that are plotted. So here's the first point, so I have one answer. Now if that answer is not there, I will change them to decimal by bottom out, and then you will get this answer. If that answer is still not there, I would change this guy to percent by moving twice to the right. 1, 2, so the answer could also be 20%. So right now the answer to 10th, 0.2 or 20%. If none of these three answers are there, that means that I need to simplify. So I'm going to get to 10th, and I'm going to simplify. I'm going to find a number that can go into both, which will be 2, 2. Am I recording? Oh yeah, I'm recording good. Just making sure. Talking by myself here in my room, and then I won't be recording. 2 divided by 2 would be 1. 10 divided by 2 would be 5. So guys, this is the answer to 10th, but if that's not it there, you need to change it to decimal. If that's still not there, you need to change to percent. If that's still not there, I need to go and simplify that fraction. Now again, here's the other point. This would be the answer, but if the answer is not there, I'm going to change it to decimal, which is 0.8. If that answer is not there, I'm going to change it to percent, which is 80% by moving twice to the right. 1, 2. If that answer is not there, I need to simplify. Divided by 2, 2 again. You think of a number that can give you both. So 2, 2 can give you 8 times 4. 2 can give you 10 times 5. Now this is simplified. So in this case, there's 1, 2, 3, 4 possible answers. The original, by us just counting the lines, changing it to decimal by bottom out, changing it to percent by twice to the right, or simplifying. Okay, you can try the top one by yourself to practice. The next one, we have an inequality. This is called an inequality, not an equation. The reason it's called an inequality is because of the less than symbol. So let me copy that. 8w is less than 120. When we have an algebraic, you see that w inequality, I'm going to use that m. So we can find out what that w means. Now what is that m? The s means subtract, the a means add, the d means divide, the m means multiply. A number next to a letter means multiply. So to solve for w, I'm going to do the inverse of multiply, which is to divide. Divide by 8, that cancels. Bring down the w, bring down the symbol. But what you do to one side, you do to the other, divided by 8. So then I'm going to go bottom out, bottom out. 1, is that enough? No. 12, is that enough? Yes. 12 minus 8 would be 4. 40, is that enough? Yes. And there it is. W is less than 15. This is a real answer. And the one that has that is letter B. So the way I did this one, you can practice this one by yourself. Again, we just solve for W by doing the inverse, but divided by 8, bottom out, and you'll find the answer. Okay, there are 81 balls at the gym. The ratio of the number of baseballs to the number of footballs is 7 to 2. How many balls are footballs? So my question was footballs. They mentioned the word ratio. When they want ratio, I'm going to do a proportion. They mentioned the word 2. That tells me that baseballs would go first. I'm going to put BB for baseballs. And after 2, we have footballs. So footballs will go second. You see that 7 right there? He was first, so he must be the baseballs. You see the 2 right there? He goes second, so he must be the footballs. You see the third number? That's 81 balls. Now, because they mention balls, I cannot put it here because the top is for baseballs, the bottom is for football. So when that happens, that the third number happens to be the total, because that's what it is. This is the total balls. I need to figure out the total of this then. So how do I figure out the total? I add 7 plus 2 would be 9. So my new ratio that I really want would be 9 on the bottom because that's the total. And since my question wants footballs, I don't care about baseballs. I'm going to go get the football, which is 2. Football. Now we can do the proportion because now it's footballs to total. Now that 81, I can actually put them on the bottom with the total, and this will become x. Now we're ready to go. 9 times x would be 9x. 81 times 2 would be 162. Divided by 9, cancel. Divided by 9, x equals something. I'm going to go bottom up. 162 divided by 9. Since it's left over, so divided by 8. I mean times 8, I'm sorry. So how many were footballs? 18 out of the 81. Now, be careful, guys, because some of you would probably put the 18, I mean, the 81 somewhere over there and mess up the whole thing. The 81 clearly said that it was the total balls. The top number is baseballs, the bottom one number is footballs. So how did I get the total? By adding them. That's how I got the 9. Okay. The next one is about ratios again. So I'm going to do a proportion. And look for the word to. Aquí está. And who came first? Coffee. So let me put a C there. Who came second? Hot chocolate. So let me put an HC right there. Now we look at the ratio. Who came first? 3. Who came second? 5. So the answer right now is 3 to 5. But it says complete the table to show the relationship. So they want you to come up with the other numbers. They don't have a third number, so we can do what we did on the top, which is solve for x. So how do I come up with the other numbers? Well, you start skip counting. 3, 6, 9, 12, 15, 18, and that's enough for now. Go to the bottom and skip count now by fives. 5, 10, 15, 20, 25, 30. So what are the answers for the table? We can have the pair of 610, the 915, 1220, 1525, 1830. And you can test, because if I would do this, guys, what's 10 times 3? 30. What's 5 times 6? 30. So I know I'm right. I could test it with the next one. 15 times 3 would be 45. 5 times 9 would still be 45. So my proportion again is correct. That information. Okay. But in this problem, all they want you to do is you finish the table. So they want you to finish the table, so your table is gonna have 6 and 10 together, 9 to 15 together, 12 to 20 together, 15 to 25 together, and 18 to 30. How did I get those numbers? I just kept counting 3, 6, 9, 12, 15, 18, and the bottom 5, 10, 15, 20, 25, 30. Okay. This one we did last week. We have a table and we have equations. So when we have that, I already told you that you're going to use the last ones. You're going to use the last one. We're going to use the 10 and the 33. Why those? Because those are the last ones in the table. Now you see the B, he gets the 10. You see the C, he gets the 33. That's your first job. To know what you're going to use, I'm going to use 10 and 33. And when do we do this? When we have a table already for us and we have equations. Now we start testing the equations. Letter A, C equals 13B. The C, I go to my table, here's a C, and what are we going to use? 33. So that C becomes 33. I'm substituting 13. A number next to a letter means times. I want to put parentheses for times. B, go to your B, and who are you going to use? The last one again, 10. Now that all those variables became a number, we can actually solve. 13 times 10 would be 130. And that is not equal, so that cannot be the equation. Then we can bubble around and copy letter B. B says C equals B plus 23. Who's the C? I go to my table and the C is 33. Who's the B? I go to my table and the table says that B is what? 10. Once we're done, we add it. That would give me 40. Oh, I messed up. Look how I messed up. This was 2. I don't know why Mr. Rivera's putting a 3. It's 2. So it's not even 4. You have to be careful, guys. Let me put it again. It's really 23. I don't know why Mr. Rivera changed it to 33. 10 plus 23 would be 33, and 33 equals 33. So choice B is probably the table that goes with that equation, which is this one. So choice B worked. Let me check choice C. C equals 3B. That's my equation. I get it from here. That C becomes 33 times that B becomes 10. 3 times 10 is 30, and that is not equal to 33. That's why that's not the answer. Now, not here. That cannot be the answer because we actually found one, which is B. Now, if A, B, and C would not have worked, then D would be the answer. But in this case, B worked. Again, change these letters from the equations to the numbers using the table. C was here, B was there. Okay. The next one. Let me pause again. I need to drink some water. Okay, I'm back, but I'm back as an anime. Okay, just to play around with you all, so you can have a little bit of fun. So right now I'm an anime now, just so you can see that I just became one anime, just for you. Yep, just for you. Okay, the next one. What percentage of the 50-acre farm has crops growing on it? So they have the word percentage. So I could do a proportion. Percentage in math means out of 100. They want to know the percentage, so I do not know what would be on top of 100 because percent means out of 100, so I do not know that part. The 100 in percentage is always the total. The part on the top, let me read. The percentage of the 50 acre that is growing crops. So the crops would be the lemon trees. So I would just say you must be the lemon. Okay. Now, did they give me the total? Yes, they did. It's 50 acres. But they were nice because they also gave me a model, so I can actually count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5. 10 times 5 is 50. Now, the lemon trees, it says they're represented by the models. So obviously they're the shaded ones. 1, 2, 3, 4, 5. 5 times 3 is 15, 16, 17, 18, 19, which they also gave me there. So 19 would be on the top. So once you have that, we're ready to rock and roll. So 50 times x would be 50x. 100 times 19 would be 1,000. I mean 19. Yeah, 1,900. My bad. You just add the two zeros at the end. Now, how do you solve for x? We're going to use SAT M again. This means multiply. So to solve for the x, we're going to do the inverse, which is divide by 50. That cancels. What you do to one side, you do to the other. Well, we have 0, so I can cancel 1 for 1. Bottom out, 190 divided by 5. Not enough. Don't forget to put the decimal quickly at the end, guys. If there's no decimal, put it at the end. 1, is that enough? No, it's not. 19, is that enough? Yes, it is. Times 3 would be 15. Bring another 0. Times 8 would be 40. So the answer is x equals 38. So 38 over 100 is 38%, which is letter D. Okay, so that's the way you do that one. In case you want to see me again as an anime, just for you. Okay, let's go back. The next one. Okay, when you have, listen real good to this because this I also taught last week and some of you forgot in class. When you have a number next to parentheses, that means times. And if inside we have a minus, we're going to do the distributive property. When there's a minus inside or a plus inside and outside we have a times, we're going to quickly draw the arrows for distributive property. Now the arrow means multiply 38 times 251m. Then we draw another arrow for the other one. 38 times 45. When are we going to draw the arrows? When it's distributive. How do you know it's distributive? When there's a minus inside and outside it's a multiplication. Now you see that minus? Just comes down. Now we can continue solving, but we're going to go check if that one is there already. And if you notice, it's right there. That's the first part. Here's the second part. It's right there. First arrow, second arrow. So this is the answer. The answer is A in this case. Now sometimes, like this one that I'm going to do next, we have an 8 outside. Next to parentheses means times. So we can put the dot. And we have a plus inside. I said if there's a minus or plus inside and outside times, we can draw arrows. So I'm going to draw my first arrow. That first arrow means 8 times 3m plus second arrow 8 times 2. Just the way I did it here on the top. But this time when you go to the choices, 8 times 3m plus 8 times 2 is not there. So what do? I need to continue solving. 8 times 3 would be 24m, 24m, plus 8 times 2 would be 16. We go back to the choices and voila, it's right there. So the answer is choice D. Please don't forget, a number next to parentheses means times, and if inside we have a plus or we have a minus, we're going to draw the arrow to represent times, draw an arrow to represent times, and that would be, this could have been the answer, just like the top. That could have been the answer, but this answer did not want, so they wanted for me to continue simplifying the expression. So 8 times 3 is 24m, because the m was there, and 8 times 2 is 16. So the real answer that they were looking for was this guy. Okay? That's the way you do that one. The next one, I already told you that whenever we have greatest to least, I'm going to change everything to money. I'm going to make a table 2. 2.2, that's the decimal they gave me. This is the original, and I want it into money like decimals. It's already decimals, but Mr. Rivera wants money, so it will be 2.20. We add a 0 for money. 1 and 1/4. You go outside, bottom out outside. For sure, the 1 in the front tells me it's a dollar something. The 1/4 would be 25 cents. How do I find the 25 cents? You go bottom out, guys. Let me unzoom so you can see. Then we have 5.2. 5.2. To make it money, we're going to put 5.20. Then we have 2.5. That would be $2 for sure because of the 2 in front, but then the half will be 0.50. Half a dollar is 50 cents. Then we have 3/4. If you don't know, you go bottom up, but this is 75 cents. Now that we have all of our numbers, now we can put them in order from greatest to least. So we look at all the numbers, and the greatest would be this guy. So he should be first on the list. The next greatest is 250. He should be second on the list. The next greatest is 220. He'll be third on the list. The next greatest will be $1.25, fourth on the list. And finally, the last greatest is 75 cents. Now, once you have the numbers in order, now you know that this guy, the 5.2, which is built in, he'll be dragged into this box first. You drag and drop. Done with one. Number 2, which is 2.50, 2.5. So 2.50, 2.5 is this guy. So Bonham, he'll be dragged to this one. You would drag and drop into the box like teacher made. The third one, number 3, would be 2.20, and 2.20 is the top one. 2.2, if you notice on your table, he'll be dragged there. We're going again from greatest to least. So the third one is done. The fourth one is 1.25 and 75 cents. So who's next? 1.25. So we're going greatest to least. So 1.25 is this guy. And finally, 3/4 will be at the very end. The key is to change them to decimal. Please change them to decimal. That's the key. Okay. You can try the other one by yourself if you want. Right, I'll come back to these ratios. Let me take care of this one that's so easy. Please listen. When they want equivalency, that's all they want. They want you to get the equivalent. Equivalent. Equivalent of 8%. So 8%. So my first job, anytime I want equivalency, is just change everything to money. So I'm going to put my decimal there. 1, 2, twice to the left, the reversa, mommy. So I know that the 8% is 0.08. So this is the answer, 0.08. So now I go to the first choice. That's not 0.08, that's 0.8, which is 0.80. That's dumb. This would be dumb also because we just said it's 0.08. So it's not these two because they don't match the decimal. I'm going to bottom out. And when you bottom out this, I'm going to take the time in the video to bottom out. But 1 divided by 8 would be 0.125. When you bottom this guy out, okay, it would be 0.08. Isn't that what I was looking for? Yes. So the answer would be C. Again, you change everything to decimal. So I changed the one from the story to decimal. Here it is. I changed this to money, 80 cents. I changed this to money by bottom out, 0.125. I changed this to money by bottom out, 0.08. This guy was already 0.04. So the only thing that matches 0.08 is letter C. Okay. And I'm going to come back to that one. The next one. We have a circle that is divided evenly. So B degrees, B degrees, B degrees. We need to find out what that number is. Because the circle, they always equal 360. So if I go all around and got the angle, it will be 360. But they want to know what is each part. So your first job is to count how many parts are there. It's not always the same one. One, two, three, four, five, six, seven, eight. So it's eight parts. So what can I do to know which of these would be the right beat to get to 360? So kids kept told me was multiply. That's one thing. What we can actually do is divide. Why divide? Because the whole thing is 360 and I want to know each piece. So when I go 360 divided by 8, why 8? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 pieces. Here we go. 3, would that be enough? No. 36, is that enough? Mm, Let me pause the video again. And we'll continue now. Okay, so we're here. Probably was falling asleep or something. I don't know. Okay, 8 times 1 gives me 36. And that would be 8 times 4 gives me 32. And then 8 times 5 gives me 40. So I know that the answer is C. Each of these is 45, 45, 45, 45, 45, and 45 until you get. You multiply 45 times this 1, 2, 3, 4, 5, 6, 7, 8. That should give you 360. In this case, now it's not always 8, it could be 10, it could be 5, whatever the circle is, it's up to. So the reason I divided by 8 was because there was 8 parts. Okay, for the next one, we have an equation y equals 5x. So again, whenever we have an equation, we're going to write the equation y equals 5x. And we're going to check the tables. Now this one is a multiplicative table. So we're going to first check, does it go to 0 through the origin? Yes. So this is a good table already. Does this one go through the origin? Yes, it goes through the origin. So that's a good table too. Let me check the C and D. Oops. The C and D. Okay, this one does not go through the origin. You can see there. That's not a good table. That would be an additive relationship situation. So this guy's a bad table. This one is really horrible. So it's between these two. So I'm going to zoom again here so we can see it better. Whenever you have a graph, we'll call this graph A and we'll call this graph B. I need to make a table for graph A. How do I make a table? We'll start with the first point right there. That would be 0, 0, obviously. X and Y. Now we go to 1, 1, 5. That would be another point right there. So 1, 5. Remember that this guy is the X and this guy is the Y. So 1 is the X, 5 is the Y. That's where I'm getting those numbers. 2 to 10. Okay, and that's all I could get. Okay, as long as you get at least 1 point, hopefully we don't want 0, we want another type of point. Okay, especially because both of them will have 0, 0, so that's not a good point to choose. So that's why I always like to choose the last ones. Now that we know that that's the last one, you see that Y? That Y is going to become 10. So why 10? Because Y is 10. That's why that Y becomes a 10. Now 5 stays a 5. A number next to a letter means times. And the X here, see the X right there? So that X becomes a 2. 5 times 2 is 10. 10 equals 10. So this table gets another check. It looks good. Let's do check. Let's check the other table. We write the equation again. We're doing the B. We do the same thing. We're gonna get a couple of points. So for sure we're gonna get this guy, which would not be a good one to use to go test it out. Then we have here 2 is not really in the middle of nothing, so I'm not gonna get that one. I'm gonna get the for sure, guys. What Mr. Rivera means for sure is, so we'll zoom too much. Okay, let me show you what I mean for sure. So if I go one, it's not really hitting there. Two, it's not really hitting. It's kind of in between, so I'm not sure what that is. Three, it's in between. That one maybe I could do it. Three, and it's exactly half. That would be 3.5. But I don't really like to work with decimals. The one that's for sure is six. Look, if you look at six, six, it's really right there with who? Seven. So that's probably what I would get. Six, seven, six, seven. Okay. And if you don't find nothing else, that's fine. We'll use those two. So you see the y? The y is who? 7. So that y becomes a 7. The 5 stays the same. The x, the number next to the letter means multiply. The x in this case becomes a 6. And 5 times 6 will be 30, and that does not equal 7. So that's why choice B is bad. And like I said, choice C, this would be choice C, and choice D. Those were bad in the beginning because they didn't go through the origin. They went through here. We need to go through the origin if it's a multiplicative. If it's an additive, then these two will be good. This one was multiplicative. That's how you do those. Now let's go back to the ones that I said I'm going to come back later. Okay. So, or did I do those already? Let me see. I don't even know what I did already. Okay, did that one. We did that one. We did that. We did multiplying. Some of those tables. Practice here the rules, guys. We did some more rules. We did that one of percentages. We did expressions. No, I haven't done it yet, so let me go to that one then. This guy. So let me do the ones with the balls. There are 81 balls at the gym. The ratio of the number of baseballs to the number of footballs is 7:2. So as soon as I saw the word ratio, listen, as soon as you see the word ratio, I know Mr. Rivera is going to want a proportion to two ratios that are equal. Now you see the word two. The word two tells me who goes first, baseballs. Who goes second, footballs. Who goes first, 7. Who goes second, 2. 7 to 2. Now, I see 81 balls, but that would be the total. The problem is some of you are going to put it here, but we can't put it here because this is the baseballs and this is footballs. Now, this question is asking for how many balls are footballs. So for sure, I do need the 2. I really don't need a 7 though, because my third number is the total. So I'm gonna have to redo this ratio and say, okay, I need the 2 because that's footballs. I do not need the 7. I need the total. I need the total. Now, if there's 7 baseballs and 2 footballs, how many balls would you do? You add them up and you would get 9. So the 9 is total. Now we can set up the proportion. Now we can put the 81 right here because that would be the total, and here's what we're missing. So now we just do our algebraic. 9 times x would be 9x. 81 times 2 would be 162. Okay, and that you just go to the side and multiply 81 times 2, 16. Oh, I messed up. 176 should have been the answer. I mean 172, my bad. 172. That's why we should not be doing mental math because then we'll make a mistake like I just did. 2 times 1 is 2. 2 times 8 is 16. Oh no, it's correct then. Yeah, we're fine. We're fine. It's not 172, it's 162. Okay. Divided by 9, divided by 9. X equals, bottom out that. So I'm going to go again to the side. 162 divided by 9. That would be 1. Bring down the 2. And that will be 8. So 18 would be the answer. So how many are footballs? 18. What worries me again is, please don't just put the 81 here, because this is baseballs to footballs. 81 in this story is total. So I had to go find a total so we can use that 81. And how do you find it? I just added the two baseballs with the two footballs with the 7 baseballs. That gives me the total. Okay. The next one, we see a ratio again, and we see the word to. So it's coffee to chocolate, hot chocolate. So I know I'm gonna do a proportion. Consider wants that. Coffee goes on top. I'm gonna put just a C this time, and hot chocolate goes on the bottom. I'm gonna put HC. Now look at these numbers. 3 to 5. Who's first? 3. That goes on the coffee. 5 goes on the hot chocolate. Now we don't have a third number. Like over here, we had the 81 as a third number. We don't have that. As a matter of fact, we're gonna have to complete a table. We're gonna make a table. To make a table, we just skip counting. 3, 6, 5, 10. 3, 6, 9 again will be over here. 5, 10, 15 will be there. 3, 6, 9, 12, 5, 10, 15, 20. 3, 6, 9, 12, 15. You do a couple of them. 5, 10, 15, 20, 25. 3, 6, 9, 12, 15, 20. 5, 10, 15, 20, 25, 30. All these are the answers. So if I need to complete a table, you'll probably have like a table like this. And we have coffee and hot chocolate. And all I did is 3 with 6. I mean, my bad, not 3 with 6. 3 with 5. 6 with 10. 9 with 15. 12 with 20. 15 with 25. And 20 with 30. That's how you complete the table. You just drop down the menu 3, 5, 6 to 10, 9 to 15. And how I did, I just kept counting 3, 6, 9, 12, 15, 20, 5, 10, 15, 20, 25, 30. Okay? And that's about it. I mean, I cannot think of anything. The rest of the stuff that would be, if they would ask you something else that I haven't taught, you just try your best. Simple as that. Okay? So, like, I haven't taught you the area of the trapezoids, but if you say for tutorial, I did trapezoid. If you say for tutorial, I did triangle. So you could probably come up with that one. Remember that when we're doing uh, greatest to least, change everything to money. 950, 9 whatever, and so on. Bottom out, like this guy would be 950. This one would be $9 and something, so I need to go bottom out 3/8. That would be 3, 7, That's a 4, by the way. 0.375. So it's going to be 9.37. You don't have to put the 5. We're thinking of money. This guy would be $9.12. This guy would be $9 and something. You see the 3/4? You go bottom out 3/4. Some of you know them by memory, 75 cents. Once you have everything in money, they want to know greatest to least. Well, who's the greatest money? This guy. So this guy goes first. Who's the next greatest number? This guy. So he will go second. And then third and fourth. You just put them in order. Okay? So you probably have to drag them and drop and whatever it is. Trapezoid. Okay. We talked about credit cards. I already did this one too, right? Yeah. Yeah, top over here. Right there. Not there. Where is it? I know we didn't, no? Right here. Okay, we try all the choices and we use the last two sets and we substitute. Okay, I think we're done. Okay, I finished off as an anime, so I'm gonna go ahead and stop it here. It's a long video, it's about an hour and 42. Watch it throughout the day tomorrow if you have a chance. Watch it at the end of the day. Practice, uh, and so like that you can get ready for Wednesday. Please do not be absent, and I see you on Wednesday.